Welcome back to the deep dive. I want you to just take a second and imagine a scenario with me. Think about the specific thing you reach for when you've had a really long, stressful week.
Right. Or maybe when you're celebrating a milestone.
Exactly. Or, maybe you're just craving something rich to pair with your evening coffee. For a massive portion of us, that thing is chocolate.
Undoubtedly.
Yeah.
It's the universal comfort food.
Yeah. But what if that specific indulgence? What if it wasn't actually a guilty pleasure at all? What if consuming it wasn't a lapse in your diet, but actually a highly effective biological intervention?
Now that is a paradigm shift.
It really is. For you, the learner listening right now, the person who actively wants to stay informed and optimize their well-being without completely sacrificing the joy of a good dessert, I mean, this is an incredibly compelling premise.
It's the holy grail of nutrition, really.
Yeah.
Eating something delicious that actively heals you.
Right. So today, our mission is to cut through the colorful marketing on the candy aisle and look strictly at the hard, clinical science of dark chocolate.
And I should jump in here and say, the scientific literature we are looking at today is undeniably fascinating, but it demands a very high level of precision from us.
Yeah, we have to be specific.
Exactly. Because if we are going to treat a food source as a physiological tool, we have to establish a strict boundary between confectionery candy and actual bioactive compounds.
Which means we are bringing some serious receipts today.
We absolutely are. To do that, we are looking at a very specific stack of research. We will be analyzing a massive 2024 prospective cohort study from the BMJ that tracked nearly 200,000 people over several decades.
200,000 people, that's not a small sample size.
No, it's monumental. We're also going to break down rigorous, randomized controlled trials that measure everything from the behavior of your gut bacteria to the physical volume of your brain tissue.
Which is still wild to me.
It gets better. We also have some highly detailed meta-analyses on oxidative stress. My primary goal today is to challenge you, the listener, to think critically about the mechanics of nutrition. We shouldn't just be asking if a certain food is quote-unquote, good or bad.
Right, those labels are kind of useless.
Completely useless.
Yeah.
We need to ask what specific compounds are in that food, how they survive the digestive process, and exactly how they interact with our cellular biology once they are inside us.
Okay, let's unpack this. Because jumping straight into modern clinical trials about gut bacteria feels like skipping to the final chapter of a very long book.
Fair point. Context is everything.
Yeah, to understand why this specific plant interacts with human biology the way it does, we have to look backward. This isn't something invented in a 20th century factory.
Far from it.
Right. The human relationship with cacao actually starts in ancient Mesoamerica, predominantly with Maya, who are the first known cultivators of the plant.
And their usage of it was, well, it was radically different from how we consume it today.
Totally. If you were to hand an ancient Mayan a modern foil-wrapped chocolate bar, they probably wouldn't even know what to do with it. They didn't consume it as a solid sweet block.
No, they drank it.
Yeah, they roasted the beans, ground them into a paste, and created this hot, incredibly bitter, frothy beverage. And the ingredients they mixed into it are really telling, I think.
The ingredients are actually the most biochemically fascinating part of the historical record.
Right, because they weren't using milk or sugar. They were adding hot water, fiery chili peppers, and spices like cinnamon.
And looking at those indigenous culinary practices through the lens of modern biochemistry often reveals a really sophisticated, almost intuitive understanding of human physiology.
How so? Like they were just trying to make it taste good.
Well, maybe. But when we analyze that specific ancient recipe today, it looks less like a beverage and much more like a carefully engineered delivery system for phytochemicals.
Okay, you're going to have to break that down for me.
Let's do it. First, consuming the cacao as a hot liquid is crucial. Heat acts as an extraction method. It actively increases the solubility and the ultimate bioavailability of the active compounds that are trapped inside the cellular matrix of the raw cacao bean.
So the hot water pulls the medicine out of the plant?
Exactly.
Yeah.
But the addition of the spices is where it gets highly technical from a metabolic standpoint. Chili peppers contain a bioactive alkaloid called piperine. Cinnamon contains a compound called cinnamaldehyde.
Okay.
When you introduce piperine into the human digestive tract, it doesn't just sit there. It actively inhibits certain digestive enzymes and actually slows down the liver's metabolic pathways.
Wait, slow down. You're saying the pepper isn't just for a spicy flavor kick, it's actively changing how the liver processes the drink.
It alters the pharmacokinetics entirely.
That is insane.
It really is. By temporarily inhibiting the liver's ability to clear foreign compounds, the piperine allows the active molecules in the cacao to remain in the bloodstream much longer and at much higher concentrations.
Wow.
Food scientists refer to this as food synergy. The Maya obviously might not have had microscopes to observe hepatic enzymes, but through generations of empirical observation, they figured out how to physically maximize the biological impact of the plant.
They recognized its physiological power.
Yes, which is likely why it was strictly reserved for royalty, warriors, and sacred religious rituals.
They took it so seriously that they literally called it the food of the gods. And that cultural reverence is actually baked into the science we use today.
It's permanently attached to it, yeah.
Because when the Spanish conquistador Hernán Cortés arrived in the 16th century, he encountered this bitter, spicy drink and brought the cacao beans back to King Charles of Spain.
And the European aristocracy went absolutely crazy for it.
They completely did. Fast forward a couple of centuries, and the renowned Swedish botanist Carl Linnaeus, the guy who basically invented our modern system of naming and classifying organisms, he had to give the cacao plant its official scientific name.
Right, you had to categorize it globally.
Yeah, and he chose the name Theobroma cacao. If you translate Theobroma from its Greek roots, it literally means food of the gods.
I love that.
It's so cool. So that ancient indigenous reverence was permanently codified into our modern botanical taxonomy.
Which is a perfect segue, because it forces us to clearly define our terms for the rest of this discussion.
Let's define them.
When Linnaeus named the tree, he was talking about the raw botanical source, the actual plant. When we talk about the health benefits of dark chocolate today, we have to be extremely specific about what that means in a modern commercial grocery store context.
Right, because a lot of what's out there isn't really Theobroma cacao anymore.
Exactly. The clinical outcomes we are going to explore today are tied directly to the percentage of actual cacao solids present in the food.
The dark, bitter stuff.
Yes. By legal definition in many regions, a product can be officially labeled as dark chocolate if it contains somewhere around 35% to 43% cocoa solids.
35% seems incredibly low.
It is. From a clinical perspective, a 35% bar is mostly just refined sugar and fat. It doesn't contain nearly enough of the active compounds to trigger any kind of therapeutic response in the body.
So what's the magic number?
To cross the threshold from a sweet treat into a functional food, the clinical literature generally points to a minimum of 70% cocoa solids, and often much higher.
I feel like this is the perfect time to address the imposter in the candy aisle.
Oh, I know where you're going with this.
We have to talk about white chocolate. I know people love it. I know it's popular around the holidays, but calling it chocolate feels like a massive biological stretch.
It's a culinary fiction.
It essentially is. It's just cocoa butter, which is just the fat extracted from the bean mixed with massive amounts of refined sugar and dairy milk powder.
There are 0 cocoa solids in it.
Exactly. It has 0 cocoa solids. It is entirely devoid of the brown, bitter material where all the actual biological magic happens.
It's just sweet fat.
So, for you listening right now, do a quick mental inventory. Think about the chocolate currently sitting in your pantry or stashed in your desk or at work.
Be honest with yourself.
Yeah. Are you working with a 30% milk chocolate bar? Is it a white chocolate truffle? Or do you actually have a solid 75% or 85% dark chocolate bar?
That distinction is everything, because those cocoa solids in the high percentage bars are the exclusive reservoir for the bioactive compounds that drive all the data we're analyzing today.
What are those compounds specifically?
We are primarily focusing on a class of molecules called polyphenols. Within that broad category, cacao is exceptionally rich in specific flavonoids, namely catechins, epicatechins, and proanthocyanidins.
That is a mouthful.
They are highly complex molecules. They function as systemic antioxidants, but as we'll see, they do much more than just scavenge free radicals. Alongside the polyphenols, cacao solids also contain a very unique alkaloid called theobromine.
Now, I've seen theobromine compared to caffeine a lot online. Is it basically just another stimulant, like a coffee substitute?
They are structurally similar. They both belong to a class of compounds called methylxanthines, but they interact with the human nervous system very differently.
How so?
Caffeine binds very aggressively to adenosine receptors in the brain. That's what gives you that sharp, immediate spike in alertness. But it also causes the jitteriness and the inevitable subsequent crash.
Right, the 2 p.m. coffee crash.
Exactly. Theobromine has a much weaker affinity for those specific receptors. It functions as a very mild, sustained psychostimulant. You don't really crash from it. But more importantly for our discussion today, theobromine acts as a diuretic, and it is a known vasodilator.
Meaning it physically widens the blood vessels.
Precisely. And if you were wondering how to tell if your chocolate has a lot of theobromine in it, you just have to taste it. Theobromine is the primary compound responsible for that sharp, astringent bitterness.
So bitterness equals bioactive power.
The more bitter the chocolate, the higher the concentration of these active heart-healthy compounds.
Okay, well, if theobromine is a vasodilator, that feels like the absolute perfect entry point into the cardiovascular data.
It's where the most dramatic numbers are.
Because when I first looked at the sources for this deep dive, the statistics on heart health seemed almost too good to be true. I'm usually pretty skeptical when a single food is touted as a cure-all, but the epidemiological data here is incredibly robust.
It's undeniable at this point.
We are looking at studies that track tens of thousands of people over long periods. The numbers they are pulling are phenomenal.
Walk us through the stats.
For instance, the data suggests that eating dark chocolate at least 5 times a week is linked to a 57% lower risk of ischemic heart disease.
57%.
A 57% reduction is the kind of number you usually only see with heavy pharmaceutical interventions.
Or massive lifestyle overhauls.
Right. Furthermore, consuming just 4 to 5 small squares a day correlates with a 17% reduced risk of hemorrhagic stroke, a 13% reduction in brain infarctions, and a 12% drop in heart attacks.
And that's just from a few squares a day.
And if we look at heart failure specifically, eating 12 to 15 squares a week lowers the risk by 15%. I just have to ask, as a clinician, how is a piece of chocolate physically engineering these kinds of outcomes in the cardiovascular system?
The mechanisms behind those numbers are what make this specific field of nutritional science so compelling. It is not abstract magic. It is observable, measurable, vascular chemistry.
Let's get into the chemistry.
Let's look at the endothelial cells. These are the specialized, incredibly thin cells that line the entire interior surface of your vascular system. Every single artery, every vein, every tiny capillary.
The inner wallpaper of the pipes.
Great analogy. When you consume high-percentage dark chocolate, those specific polyphenols we mentioned earlier, particularly the epicatechins, survive your digestive process and enter your bloodstream.
Okay.
As they circulate, they interact directly with these endothelial cells. They act as a chemical signaling mechanism, literally stimulating the endothelium to drastically increase its production of nitric oxide.
Nitric oxide, or NO. I know that's a term that gets thrown around a lot in fitness communities. Usually it's in the context of pre-workout supplements trying to get a quote-unquote pump in the muscles. But what is it actually doing naturally inside an artery?
Nitric oxide is a gas, and it functions as a highly potent transient biological messenger. When the endothelial cells release this nitric oxide, it diffuses directly into the smooth muscle cells that wrap around the outside of your arteries.
Okay, so it leaves the inner lining and goes into the muscle layer.
Exactly. And it triggers a biochemical cascade inside the muscle cell that essentially tells it to stop contracting and to relax.
It tells the artery to chill out.
Yes. When that smooth muscle relaxes, the physical diameter of the artery widens. This is vasodilation. When the pipe gets wider, the fluid inside, which is your blood, encounters significantly less resistance.
Right, because there's more room.
Blood flows much more efficiently, and as a direct physical result, your systemic blood pressure drops.
It's literally like taking a kinked garden hose that you've been squeezing tightly in your fist and finally releasing your grip.
That is the exact mechanical process.
The pump, which is your heart, doesn't have to work nearly as hard to push the water through.
It saves the heart a tremendous amount of mechanical stress over time.
But the sources point to another mechanism too, something called ACE inhibition. Now, for anyone listening who has a parent or a grandparent dealing with hypertension, that acronym is probably very familiar.
It's one of the most common prescriptions on the planet.
Right. Doctors prescribe synthetic medications called ACE inhibitors every single day.
Are the sources implying that dark chocolate is doing the exact same biological thing as a prescription blood pressure drug?
It is utilizing the exact same biological pathway, yes.
That is incredible.
ACE stands for angiotensin-converting enzyme. The human body has a very complex system for regulating blood pressure called the renin-angiotensin-aldosterone system.
Say that 5 times fast. I'd rather not. But ACE is a critical enzyme in this system. Its primary job is to convert a hormone called angiotensin I into angiotensin II.
And what does angiotensin II do?
Angiotensin II is a highly powerful vasoconstrictor. It binds to receptors on the blood vessels and forces them to clamp down, aggressively raising your blood pressure.
So it's the opposite of nitric oxide.
Exactly. Now, the polyphenols found abundantly in high-quality dark chocolate have been shown to physically bind to and inhibit the activity of that angiotensin-converting enzyme.
So they stop the body from making the chemical that squeezes the pipes.
Precisely. So you aren't just getting a single benefit here. You're getting a synchronized, dual-action vascular therapy. The nitric oxide is actively forcing the vessels to open, while the ACE inhibition is simultaneously preventing the body's hormones from forcing them closed.
That is a brilliant biological 1-2 punch.
It's elegant biochemistry.
But keeping the blood vessels wide open is really only part of the battle, right? We also have to worry about the actual structural integrity of the arteries themselves as we age.
Absolutely. The physical structural degradation of the vascular system is a primary driver of cardiovascular disease. As we age, or as we accumulate oxidative damage from poor diets or stress, our arteries tend to lose their youthful elasticity. They become stiff.
Like an old rubber band that's been left in the sun.
Yes. And arterial stiffness is incredibly dangerous because a stiff artery cannot expand to absorb the pulsating high-pressure wave of the heartbeat. That shock wave then travels down and damages the delicate microvasculature downstream, particularly in the brain and the kidneys.
So the force of the heartbeat literally damages the smaller organs.
Yes, but the clinical literature demonstrates that regular consumption of highly concentrated cacao polyphenols significantly preserves and even improves arterial elasticity.
Yeah.
Furthermore, these compounds actively interfere with the calcification process.
Calcification, like calcium physically building up where it shouldn't be.
Correct. When there is chronic inflammation in the arterial wall, calcium and fatty deposits begin to accumulate, hardening into atherosclerotic plaques. This is what we commonly call the hardening of the arteries.
The plaque buildup that leads to a heart attack.
Exactly. The bioactive compounds in dark chocolate help modulate the inflammatory response in the endothelium, physically limiting the deposition of these plaques. It is actively keeping the plumbing of the human body pliable, clean, and functionally youthful.
Okay, I have to play devil's advocate here for a second because we need to issue a very clear safety caveat for the listener.
Always a good idea.
If dark chocolate is this incredibly potent at driving down blood pressure, if it's acting as a dual-action vasodilator and a natural ACE inhibitor, what happens to someone who doesn't have hypertension?
Ah, I see what you're asking.
If my blood pressure is perfectly normal or even naturally a little bit low, and I eat half a bar of 85% dark chocolate, am I going to pass out? Is it going to force my blood pressure into a dangerously low state?
That is a very logical concern, but it fundamentally misunderstands how dietary interventions differ from synthetic pharmaceuticals.
Oh.
The clinical evidence shows that this profound blood pressure reduction is overwhelmingly observed in individuals who already have elevated or stage 1 hypertension. The human body operates on a principle of homeostasis. It is constantly self-regulating to maintain a stable internal environment.
Right, the body wants to stay balanced.
Exactly. The polyphenols in dark chocolate don't blindly override the body's homeostatic mechanisms like a drug might. They support them. If your blood pressure is already in a healthy, normal range, your endothelial cells and your renin-angiotensin system are already functioning properly.
So the chocolate doesn't break a system that's already working.
Correct. Introducing dark chocolate in that scenario will provide systemic antioxidant protection, but it will not artificially force your blood pressure down into a hypotensive crisis. It helps normalize excessive pressure. It doesn't arbitrarily drive normal pressure into a deficit.
That makes a lot of sense. It's bringing a malfunctioning system back to baseline, not pushing a perfectly healthy system off a cliff.
That's a great way to summarize it.
Now, let's completely pivot from the cardiovascular system to something that frankly broke my brain when I first read the outline for this deep dive.
Metabolic data.
Yes.
Yeah.
I want to talk about what we're going to call the diabetes paradox. Because rationally, when we think of chocolate, we think of candy. And when we think of candy, we think of sugar.
And sugar leads to insulin resistance.
Exactly. When we think of chronic sugar consumption, we think of insulin resistance and a massive increased risk for type 2 diabetes. But the 2024 massive cohort study from the BMJ completely upends that assumption.
It rewrites the narrative entirely.
It really does. And before we get into the results, we have to establish the scale of this study because it is staggering. The researchers didn't just look at a few dozen people for a month.
No, the statistical power here is immense.
They pooled decades of data from 3 of the most famous, rigorous epidemiological cohorts in U.S. history: the Nurses' Health Study first, the Nurses' Health Study 2, and the Health Professionals Follow-Up Study.
The scale of the data here is paramount to understanding the validity of the findings. We are looking at a combined pool of 192,208 participants. Almost 200,000 people. Yes. And because these specific participants were meticulously followed for decades, the researchers amassed over 4.8 million person-years of follow-up data. 4.8 million person-years. That's hard to even conceptualize. They tracked dietary habits, lifestyle factors, and disease outcomes with meticulous detail through validated, repeated questionnaires over the course of their lives. When you have a data set that massive, you aren't just looking for random statistical noise. You're able to identify deeply entrenched long-term biological trends with an incredibly high degree of confidence.
And the initial top-line finding of the study was already surprising to me. They looked at total chocolate intake, meaning they literally lumped everyone who ate chocolate into one giant group, regardless of whether it was a dark chocolate bar, a milk chocolate bunny, or a chocolate chip cookie.
A very broad categorization.
Yeah. Right. And even then, they found that participants who consumed 5 or more servings of any chocolate a week had a 10% lower rate of developing type 2 diabetes compared to the people who rarely or never ate chocolate.
A 10% reduction just for eating general chocolate is wild.
It is wild. But then the researchers dug deeper. They separated the data by the specific type of chocolate the participants were eating. And that is where the results split wide open.
Yes, the subtype analysis is where the true pharmacological power of the cacao plant reveals itself. When the researchers isolated the participants who were consuming 5 or more servings a week specifically of dark chocolate, that 10% risk reduction didn't just hold steady.
It jumped.
It more than doubled. The data showed a 21% lower risk of developing type 2 diabetes for the dark chocolate group.
21%. How did they even map that? Because humans don't just eat exactly 5 servings of chocolate every single week for 30 years. Diets naturally fluctuate.
Of course they do.
So how do you find a clear line connecting dark chocolate to diabetes prevention in a messy data set of almost 200,000 real living people?
They utilized a highly sophisticated statistical modeling technique called spline regression.
Spline regression.
That's
Okay,
it.
simplify that for us.
To understand this, imagine plotting human behavior on a graph. If you use a standard linear regression, you are basically forcing a rigid, straight line through a messy scatter plot of dots.
Which kind of ignores the nuance.
Exactly. It often oversimplifies or entirely misses the nuances of biological reality. A spline regression doesn't force a straight line. It uses mathematical knots to allow the curve to bend and flex organically through the data points, revealing the true shape of the relationship across different levels of consumption.
So it maps to how people actually behave and eat.
Yes, and by applying this model, they discovered a beautifully clear, linear dose-response association specifically for dark chocolate.
Meaning the more you eat, the better the result.
Up to a point, yes. They calculated a statistically significant 3% risk reduction for developing type 2 diabetes for every single serving of dark chocolate consumed per week.
A 3% reduction per serving per week.
Compounding over time.
That is a measurable cumulative armor against metabolic dysfunction. But I know exactly what the listener is thinking right now.
They want to eat a bag of candy.
They're thinking, great, I'm going to go buy a massive bag of milk chocolate peanut butter cups and eat 5 a day to protect my pancreas. We have to throw cold water on that idea right now. Let's look at the data for milk chocolate.
We must, because this is where the strict boundary between confectionery and functional food is drawn permanently. The spline regression models and the subtype analyses demonstrated absolutely zero significant associations between milk chocolate intake and a reduced risk of type 2 diabetes.
Zero.
The protective effect vanished entirely. In fact, the longitudinal data showed that regular milk chocolate consumption was positively associated with long-term weight gain and an adverse metabolic profile.
So mechanically, what is actually happening there? Why does adding milk and sugar to cacao completely neutralize the quote-unquote food of the gods?
It comes down to cellular context and molecular interference. The bioactive compounds in the cacao solids, the polyphenols and flavonoids, are the actual agents that protect your pancreatic beta cells and improve peripheral insulin sensitivity.
They help your body clear glucose from the blood more efficiently.
Right. However, when you dilute those trace amounts of cocoa with overwhelming amounts of refined sucrose, you are inducing massive, rapid spikes in blood glucose and insulin levels. You are fundamentally stressing the very metabolic pathways the cacao is trying to protect.
It's like trying to put out a fire with a cup of water while dumping a gallon of gasoline on it.
That's a very vivid way to put it. Furthermore, there is a physical-chemical reaction happening. The casein proteins found in dairy milk actually bind to the polyphenols in the chocolate, forming large, complex molecules.
The milk proteins physically lock up the antioxidants.
Yes. The human digestive tract has a very difficult time breaking down these specific casein polyphenol complexes. So the dairy literally prevents your intestines from absorbing the antioxidants. They pass right through you unabsorbed.
That is fascinating and honestly a bit tragic. By turning it into a sweet, creamy candy bar, we are biologically locking away the medicine.
We are rendering it inert.
We are paying a massive metabolic penalty for the sugar and getting absolutely none of the physiological benefits of the cacao. It demands that we stop grouping them together in our minds. A 15% milk chocolate bar and an 85% dark chocolate bar are as biologically distinct as a glass of soda and a cup of green tea.
They belong in completely different nutritional categories.
Absolutely. Okay, let's shift gears entirely. We've talked about the heart and the pancreas, the physical metabolism. I want to venture into territory that, honestly, a decade ago would have sounded like absolute science fiction, but today is supported by incredibly rigorous data.
The microbiome.
Yes. I want to talk about the gut-brain axis. How can the physical act of chewing and swallowing a piece of dark chocolate fundamentally alter your mood, your emotional resilience, and your subjective experience of reality?
It's one of the most exciting frontiers in medicine right now.
To unpack this, we are looking at a remarkable randomized controlled trial published in the Journal of Nutritional Biochemistry in 2022. This wasn't a sprawling, decades-long epidemiological study. This was a tightly controlled 3-week trial focusing on healthy adults aged 20 to 30.
A very specific demographic.
They assigned them to eat exactly 30 grams of chocolate every single day.
And the architecture of this trial is exceptional because it was designed specifically to test the threshold limits we established earlier about cocoa percentages. They didn't just compare chocolate to no chocolate.
Right, they stratified it.
They divided the young adults into 3 distinct groups. Group 1 was given 30 grams of 85% cocoa dark chocolate daily. Group 2 was given 30 grams of 70% cocoa dark chocolate. And Group 3 was the control, consuming absolutely no chocolate.
And how did they measure their mood? You can't just ask, how do you feel today?
No, to measure the psychological outcomes accurately, they utilized the positive and negative affect schedule, commonly known in research as the PANAS scale.
What does that track?
It is a highly validated psychometric tool used widely in clinical psychology to quantify variations in a person's emotional state measure, specific things like distress, irritability, enthusiasm, and alertness.
So this is the ultimate showdown, 85% versus 70%. And the results were completely unexpected.
They really challenged the conventional wisdom.
Because generally, in the health community, 70% dark chocolate is considered the gold standard starting point. It's the widely accepted healthy chocolate. But in this specific study, looking purely at psychological metrics, the 70% chocolate failed.
It didn't move the needle.
Only the group eating the 85% dark chocolate showed a statistically significant reduction in negative affect. The young adults eating the highly concentrated 85% cacao literally experienced fewer bad moods, a noticeable drop in baseline irritability, and lower overall emotional distress compared to both the 70% group and the control group.
And the researchers didn't just hand out questionnaires and call it a day.
No, they wanted to know why.
They wanted to know exactly how the chocolate was physically changing their minds, so they looked inside their intestines.
This is where the intersection of nutrition and neuroscience gets truly breathtaking.
The researchers collected stool samples from the participants and performed a cutting-edge technique called fecal 16S rRNA sequencing.
Okay, pretend I don't have a PhD in microbiology. What is 16S rRNA sequencing?
To give some context, historically, if scientists wanted to know what specific bacteria were living in your gut, they had to take a sample and try to grow them in a petri dish in a lab.
Which seems logical.
It does. But the vast majority of gut bacteria are completely anaerobic, meaning they die instantly when exposed to oxygen. So culturing them outside the body is incredibly difficult, if not impossible.
Oh, so we were missing most of the picture.
Exactly. But 16S RNA sequencing bypasses that limitation entirely. It extracts the raw DNA directly from the sample and sequences a very specific, highly conserved gene found in all bacteria.
Like scanning a barcode.
That is the perfect analogy. By reading this genetic barcode, researchers can identify exactly which bacterial species are present and in what specific quantities, down to an incredibly precise molecular level.
So they took a high-definition genetic snapshot of the gut microbiome before and after the 3-week chocolate intervention. What did the barcodes tell them?
The sequencing revealed that the 85% dark chocolate was functioning as a highly potent prebiotic.
Let's clarify the terminology here for the listener. Prebiotic versus probiotic.
Very important distinction. A probiotic is a live bacterial strain that you ingest, like in yogurt or a pill, hoping it survives your stomach acid to take up residence in your gut.
Right.
A prebiotic, on the other hand, is a specialized non-digestible plant fiber, or polyphenol, that passes through the upper GI tract completely intact. When it reaches the colon, it serves as an exclusive food source, selectively feeding and fertilizing the beneficial bacteria that already live there natively.
So the chocolate is the food for the good bacteria.
Yes, the data show that the 85% chocolate significantly increased the overall diversity of the gut microbiome. And in gastroenterology, microbial diversity is one of the primary biomarkers of a robust, resilient immune and digestive system.
It's fertilizer. You are essentially throwing down high-grade nitrogen fertilizer on the specific microbial garden you want to grow. But the 16S sequencing allowed them to look way closer than just general diversity, right? They found very specific shifts in bacterial populations.
Precisely. The sequencing isolated profound shifts in specific microbial taxa. They observed that the abundance of a bacterial species called Blautia obium became significantly elevated in the 85% group.
Blautia obium. Okay.
Concurrently, the levels of another bacteria, Faecalibacterium prosonense, notably decreased. Now, documenting a shift in gut flora is interesting on its own, but the researchers took it a massive step further.
They connected it to the mood scores.
They ran a complex correlational analysis directly comparing the shifts in the bacterial barcodes with the scores from the psychological PANAS test. The results were definitive. The reduction in negative affect, the tangible improvement in the participant's emotional state, was directly and statistically correlated with the increased abundance of Blautia obium in their digestive tracts.
I want to pause here because this is a truly paradigm-shifting concept for a lot of people.
It changes how we view human consciousness.
It really does. When we feel irritable or anxious or just generally distressed, we tend to view those feelings as purely cognitive events. We think it's just neurochemistry happening strictly inside our skulls, or a reaction to a bad day at work, or an argument we had.
We view it top-down.
Right. But this research is definitively proving that your emotional baseline is being actively negotiated and regulated by microscopic organisms living in your large intestine. The 85% dark chocolate selectively fed the Blautia obium, the bacterial population exploded, and through the gut-brain axis, those bacteria signaled the central nervous system to physically turn down the dial on negative motions.
And the mechanisms of that communication are incredibly intricate. The gut microbiome communicates with the brain via several distinct pathways.
How are they talking to the brain?
They produce short-chain fatty acids that enter the bloodstream and can cross the blood-brain barrier. They modulate systemic inflammation, which directly impacts neuroinflammation. And they interact directly with the vagus nerve.
The vagus nerve is huge.
It acts as a superhighway of neurological signals connecting the enteric nervous system of the gut straight to the brainstem. By altering the microbial populations with targeted prebiotics like cacao polyphenols, you are fundamentally changing the chemical messages being sent up that superhighway.
It is the ultimate biological hack. And this isn't an isolated anomaly regarding mental well-being either. The broader literature supports this. Other studies have demonstrated that consuming roughly 40 grams of dark chocolate a day can significantly reduce perceived stress levels, particularly in women, and may even alleviate certain depressive symptoms.
It challenges us to realize that our emotional resilience is inextricably linked to our gastroenterological health.
But if we are talking about the brain, I want to push this even further.
Let's do it.
If dark chocolate can modulate your mood by manipulating your gut bacteria, what can it do to the actual physical hardware of the brain itself?
This is where the structural data comes in.
Let's move from the 20-somethings to a different demographic. There's a 2022 randomized controlled trial published in the journal Behavioral Neurology that focuses on healthy middle-aged adults over a 4-week period. The primary focus of this study was cognitive decline and something we literally all deal with, the pervasive, heavy feeling of fatigue.
Fatigue is a highly complex, multi-system phenomenon. It is rarely just a simple lack of sleep.
Right, it's not just, I need a nap.
Chronic fatigue in middle-aged populations represents a systemic degradation of both physical vitality and cognitive sharpness. It's that heavy, lethargic feeling in the muscles combined with the inability to concentrate or maintain sustained attention. Brain fog.
Yeah, brain fog.
In this trial, the researchers utilized an analytical framework known as path analysis.
What is path analysis?
Path analysis is a statistical technique used to evaluate causal models by examining the direct and indirect relationships between a dependent variable and two or more independent variables. Essentially, they were trying to meticulously map out the cascading chain reaction of introducing dark chocolate into the diet.
And what was the immediate result?
The immediate finding was that regular consumption of dark chocolate directly and significantly reduced both physical fatigue and mental fatigue scores.
And what I found so brilliant about this study is how it used that path analysis to map out the domino effect of that newly unlocked energy. It didn't just say they felt less tired and went home. It tracked what happened next in their lives.
The behavioral cascade.
Yes. The researchers found that when you alleviate that core physical fatigue, the participants experienced significantly better overall physical function. They were moving more and moving better. When the body is functioning more optimally, the study noted a subsequent measurable relief in bodily pain.
Which makes sense. Movement lubricates the joints.
Right. And when you are in less pain and have more physical energy, what is the inevitable next domino? It leads directly to improved social and emotional functioning. The participants literally had the energy to engage with their families, to be mentally present at their jobs, to actively enjoy their lives.
It's a beautiful demonstration of how a targeted biochemical intervention, eating a few squares of chocolate, can cascade into a dramatically improved holistic quality of life.
But it wasn't just subjective feelings of having more energy, right?
No, the behavioral and quality of life improvements are compelling, but the path analysis also looked at objective, neurological performance, and structure. This is arguably the most remarkable data point we are discussing today.
I agree completely.
The researchers observed that the dark chocolate intervention directly and indirectly enhanced executive function.
Define executive function for the listener.
Executive function encompasses your brain's higher-level cognitive abilities, working memory, flexible thinking, self-control, and the ability to juggle multiple complex tasks simultaneously.
The CEO of brain.
Exactly. But it wasn't merely a functional boost. The study indicated that the dark chocolate intervention actually mediated gray matter volume in the brain.
Wait, I need to make sure I'm understanding this correctly. Gray matter volume. We aren't just talking about electrical signals firing faster. We're talking about the actual physical density and structural mass of the brain's processing tissue.
We're talking about literal tissue preservation.
It's analogous to taking your brain to a physical gym. When you lift heavy weights, you induce hypertrophy, building physical muscle mass in your biceps or your quads. This study is suggesting that the compounds inside dark chocolate are providing a biological stimulus that helps maintain or potentially build the physical tissue density of the brain in middle-aged adults.
It is a profound finding that speaks to the incredible neuroplasticity of the adult brain.
That is a staggering concept for anyone who is even mildly concerned about neurodegeneration or cognitive decline as they age.
To understand the true significance, we have to define gray matter. The brain is primarily composed of gray matter and white matter. Gray matter is where the vast majority of your brain's neuronal cell bodies, dendrites, and synapses actually reside.
It's the computing hardware.
It is the tissue explicitly responsible for processing information, routing sensory data, and executing motor commands. As we age, it is completely normal for gray matter volume to slowly atrophy, which correlates directly with cognitive decline. The fact that a specific dietary intervention can mediate and protect the volume of this tissue is revolutionary.
Mechanistically, how is a plant compound doing that in the brain?
The epicatechins and other flavonoids in the cacao are remarkably capable of crossing the blood-brain barrier. Once inside the brain, they exert profound anti-inflammatory effects and promote a biological process called angiogenesis.
Angiogenesis, that's the creation of new blood vessels, right?
Correct. By stimulating the growth of dense, new microcapillary networks within the brain tissue itself, The flavonoids ensure a robust, continuous supply of oxygen and glucose to the neurons.
It builds new supply lines.
They are physically upgrading the brain's supply chain, providing the exact nutrients the gray matter needs to maintain its structural integrity and volume over time.
Which brings us to the underlying villain in almost every biological process we've discussed today: oxidative stress and inflammation.
The root of cellular aging.
Because all of these incredible benefits, the vasodilation in the heart, the microbial fertilization in the gut, the tissue preservation in the brain, they're all essentially localized victories in a much larger systemic war against cellular damage. Let's look at the overarching data on this. We have a grade-assessed meta-analysis of 33 controlled trials involving 1,379 adults.
A very comprehensive review.
And for the listener, when we say grade-assessed, it means the researchers didn't just passively read the studies. They applied a very strict, standardized grading system to meticulously evaluate the actual quality, the potential bias, and the certainty of the evidence. It's the gold standard of data review. What did this massive review conclude about this biological war?
The meta-analysis was incredibly definitive on several key biomarkers. Across the synthesis of those 33 trials, it confirmed with high certainty that dark chocolate consumption significantly reduces circulating levels of a compound called MDA, or malondialdehyde.
What is MDA?
To understand why MDA matters, we have to look at how cells degrade. The membranes that encapsulate every single cell in your body are constructed from lipids or fats. When your body is subjected to metabolic stress, poor diet, or environmental toxins, it produces highly reactive molecules called free radicals.
So bad guys.
These free radicals aggressively attack and damage the lipids in your cell membranes in a destructive process called lipid peroxidation. You can conceptualize lipid peroxidation as the biological equivalent of metal rusting.
So the cells are literally rusting and degrading from the outside in.
Exactly. And when those cellular lipids rust and break down, they produce a specific measurable byproduct, malondialdehyde, or MDA.
So it's the exhaust fumes of cell death.
Therefore, MDA is a highly reliable, quantifiable biomarker for systemic oxidative stress. If your MDA levels are high, your cells are actively rusting. The meta-analysis proved that dark chocolate significantly lowers MDA levels.
Which means it stops the rusting.
This indicates that the cacao polyphenols are functioning as an active chemical shield, neutralizing the free radicals before they can initiate the lipid peroxidation process, thereby protecting the cellular architecture across the entire body. And, fully validating our earlier discussion on the cardiovascular system, this meta-analysis also definitively confirmed that dark chocolate significantly boosts systemic nitric oxide levels.
Okay, so it stops the rusting and opens the blood vessels. But when I read the analysis, it revealed a really important nuance about inflammation.
Yes, the data is very specific here.
Because the supplement industry likes to market antioxidants as magic bullets that cure all inflammation for everyone instantly. But the data here was much more nuanced, wasn't it? It didn't just wipe out all inflammatory markers across the board for every person.
That is a vital distinction, and it really highlights why actually reading the primary literature is so important instead of just the headline. The data revealed what we can term an inflammation threshold.
An inflammation threshold, explain that.
When the researchers looked at the broad general population across all the studies, dark chocolate did not significantly reduce general systemic inflammatory markers like C-reactive protein, interleukin-6, or TNF-alpha in a uniform, predictable way.
So it wasn't a universal cure-all.
It wasn't a universal cure for all baseline inflammation. However, the data revealed a specific lock and key mechanism.
A lock and key? How so?
The researchers discovered that statistically significant, powerful anti-inflammatory effects were unlocked, but only under very specific physiological conditions. These profound effects were observed exclusively when participants consumed exceptionally high doses of flavonoids, specifically greater than 450 milligrams per day.
That is a massive dose.
Furthermore, these benefits were seen over shorter intervention durations of 4 weeks or less, and most crucially, they were observed primarily in individuals who were already officially classified as non-healthy or metabolically compromised.
Let me make sure I'm translating this correctly for the listener. If you are a generally healthy person, eating dark chocolate acts as a low-level maintenance crew. It keeps the baseline oxidative stress, the MDA low, and keeps the nitric oxide flowing.
Correct.
But if you are actively suffering from acute inflammation, Or if you are metabolically compromised with a chronic condition, a high-dose, short-term burst of these specific cacao flavonoids acts like a targeted biological strike force, deploying to actively bring that elevated inflammation down.
That is a highly accurate characterization. It's an exquisite example of precision nutrition. The efficacy of the intervention is entirely dependent on the baseline state of the organism and the precise dosage of the compound.
Which brings us to the massive, frustrating hurdle we face in the real world.
The processing problem.
Yes. To deploy that biological strike force, you need to consume over 450 milligrams of flavonoids a day. To get that, you have to actually eat the chocolate. But raw, unprocessed cacao is intensely aggressively bitter. Very few people want to just eat it raw. To make it palatable, to make it something consumers will actually purchase and enjoy, the chocolate industry processes it. And that processing is a nutritional tragedy, isn't it?
It is the central paradox of the modern commercial food industry. The traditional manufacturing process is utilized to transform a raw, astringent cacao bean into a smooth, sweet, commercially viable chocolate bar, systematically destroy the exact biochemicals that make the plant valuable in the first place.
It's maddening.
The most damaging process by far is called Dutching, or alkalization.
I see processed with alkali on the back of cocoa powder tubs all the time. What is that chemical process actually doing?
Dutching involves washing the cacao beans or the cocoa mass with a strong alkaline solution, typically potassium carbonate. This aggressively raises the pH of the cacao, making it significantly less acidic.
Why do they do that?
From a culinary perspective, this is highly desirable because it dramatically darkens the color of the cocoa, making it look richer and more premium, and it severely neutralizes the harsh, bitter flavor notes, resulting in a much milder, smoother taste profile that appeals to the mass market.
So it looks better and tastes sweeter.
Yes, but from a nutritional perspective, alkalization is completely devastating. The high heat of roasting, combined with the highly alkaline environment, chemically alters and destroys the naturally occurring ascorbic acid, which is vitamin C. It degrades thiamine, an essential B vitamin.
And the polyphenols.
Most tragically, the Dutching process can actively destroy upwards of 60% to 90% of the precious polyphenols and flavanols we have spent this entire deep dive discussing. By artificially processing the cacao for maximum palatability, manufacturers literally process the medicine right out of it.
It's infuriating. You take the literal food of the gods and you refine the divinity completely out of it, leaving behind a dead husk of fat and sugar.
It's a massive missed opportunity for public health.
But I was reading a fascinating paper from Current Research in Food Science that shows food scientists aren't just accepting this. They're actively fighting back through the science of fortification. They are looking at this stripped-down, heavily processed chocolate and figuring out how to re-engineer it back into the ultimate functional food. How exactly are they hacking the modern chocolate bar?
The fortification methodologies currently being explored in the clinical literature are incredibly innovative. Food scientists have realized that while processed chocolate might lack polyphenols, it possesses a highly unique physical property. Cocoa butter.
The fat.
Yes. Cocoa butter is a highly stable, complex fat matrix. Because it is solid at room temperature but melts perfectly at human body temperature, it acts as an ideal biological Trojan horse for delivering other fragile nutrients safely through the harsh acidic environment of the human digestive tract.
Oh, that is clever.
For example, researchers are successfully fortifying dark chocolate with live probiotic cultures, specifically incredibly hardy strains of lactobacillus and bacillus. Clinical models have demonstrated that these live bacteria survive the highly acidic environment of the stomach much more effectively when they are encased in the dense fat matrix of chocolate than they do when delivered in traditional dairy yogurt.
That is brilliant. The fat physically shields the bacteria until they reach the intestines. And they aren't just stopping at probiotics, right? They are building an entire ecosystem directly into the bar.
Exactly. To ensure those probiotics thrive once they arrive in the gut, scientists are simultaneously adding complex prebiotics directly into the chocolate matrix compounds, like inulin, xanthan gum, and maltodextrin.
So they are packing the bacterial seeds and the fertilizer into the exact same delicious delivery vehicle? But how do they replace the polyphenols that the Dutching process destroyed?
They are turning to other highly concentrated botanical sources. They are actively blending in freeze-dried extracts from intensely antioxidant-rich fruits like mulberries, chokeberries, and elderberries to spike the polyphenol count exponentially higher than even raw cacao.
Creating a super chocolate?
They are also integrating complex spices like cinnamon, which, as you'll note, perfectly echoes that ancient Mayan recipe we discussed at the very beginning. And they're even adding synthesized phytosterols.
What are phytosterols?
Phytosterols are plant compounds that are structurally very similar to human cholesterol. When you consume them incorporated in chocolate, they actively compete with real cholesterol for absorption in the digestive tract,
Right.
effectively blocking it and safely lowering your systemic cholesterol levels.
It really feels like they are engineering the absolute perfect food, but I have to assume that adding freeze-dried elderberries, inulin powder, and xanthan gum to a chocolate bar completely ruins the texture. Does it just taste like a gritty, chalky protein bar at that point?
Interestingly, from a food rheology perspective, the opposite is often true.
Really?
Rheology is the study of the flow of matter, primarily in a liquid or melted state. When scientists add specific prebiotics like inulin, it can actually improve the rheological properties of the chocolate. It can enhance the physical snap of the bar when you break it, and it can significantly improve the viscosity and mouthfeel as it melts on the tongue.
So it makes it creamier.
Furthermore, by carefully integrating these naturally sweet or complex fruit and spice flavor profiles, they can effectively mask the intense, astringent bitterness of the high-percentage cocoa. This significantly improves consumer acceptance without forcing manufacturers to dump massive quantities of refined cane sugar into the vat.
It is an absolute masterclass in food engineering. They are taking our innate human desire for rich, indulgent treats and secretly packing it with functional medicine.
It's a win-win scenario.
But before the listener pauses this deep dive and runs to the health food store to buy an armful of fortified 85% dark chocolate bars, we have to pump the brakes.
Yes, we do.
There is a dark cloud hanging over the cacao industry, and the grade-assessed meta-analysis specifically called it out. We need to issue a very clear, very serious safety warning.
This is an absolutely critical public health caveat. In the comprehensive meta-analysis of those 33 clinical trials, the researchers noted a glaring, almost systematic failure across the breadth of the scientific literature. The studies completely failed to report on the risk or the measured presence of heavy metal contamination in the interventions they were using.
Why is that a problem for chocolate specifically?
Because the Theobroma cacao plant is known in botany as a bioaccumulator.
What does that mean practically? It acts like a sponge.
Essentially, yes. Depending heavily on the specific geographical region, the volcanic nature of the soil it is grown in, the agricultural practices utilized, and even the industrial methods used during processing and transport, the cacao tree can absorb and concentrate significant, highly dangerous levels of heavy metals into its beans.
What metals are we talking about?
We are specifically talking about lead and cadmium. Both of these elements are potent neurotoxins and nephrotoxins, meaning they aggressively damage the brain and the kidneys over time.
Which is the ultimate tragic irony. You are diligently eating an 85% dark chocolate bar every day because you want the flavonoids to stimulate angiogenesis and build your gray matter volume. But because the plant acts like a sponge, you are potentially simultaneously delivering a daily microdose of lead directly to your newly formed brain tissue, actively destroying the exact neurons you are trying to protect.
It completely defeats the entire purpose of the biological intervention.
So the absolute non-negotiable takeaway for you, the listener, is this. You cannot blindly trust a beautiful, artisanal-looking label at the grocery store. Organic or fair trade does not automatically mean free of heavy metals.
Not at all.
You must research the specific brands you are purchasing. You have to look for companies that transparently publish independent third-party heavy metal testing for their specific current cacao sourcing. The physiological benefits of cacao are simply too profound to risk entirely negating them by accidentally consuming tainted soil.
That cannot be overstated. Applying critical thinking in the grocery aisle is just as important as the critical thinking required in the clinical laboratory.
Absolutely.
Assuming, however, that the listener has done their due diligence, researched their brand, and found a clean, high-percentage, third-party tested bar, we should briefly touch upon the fundamental macronutritional mechanics of the food itself. Because even if we completely ignore the complex world of polyphenols, spline regressions, and 16S gut sequencing, a high-quality dark chocolate bar is simply a nutritional powerhouse on a foundational level.
A masterclass in raw nutrient density. Let's look at the raw numbers for a second, starting with magnesium. We mentioned earlier that eating just 4 small squares of a high-quality dark chocolate bar provides roughly 15% to 25% of your recommended daily allowance for magnesium.
It's incredibly dense.
A full 100-gram bar can contain upwards of 250 milligrams. Magnesium is a vital macromineral involved in over 300 distinct enzymatic reactions within the human body. It regulates everything from muscle contraction and nerve transmission to the synthesis of DNA and the regulation of sleep quality.
Most people are deficient in it too.
Exactly. And then there's the iron content. A 100-gram bar of high-percentage dark chocolate packs a massive 10 to 12 milligrams of iron. To put that in perspective, depending on your age and biological sex, eating just a few squares can seamlessly cover 15% to 40% of your entire daily iron requirement.
The concentration of minerals is impressive. But this raises a very important question regarding human digestion and actual nutrient absorption. Just because a laboratory analysis shows that a piece of food contains 12 milligrams of iron, it absolutely does not mean that 12 milligrams of iron are going to successfully make it into your bloodstream.
Why not? Iron is iron, right?
Not biologically. The specific type of iron found in dark chocolate and in all plant-based foods actually is non-heme iron. Biologically, the human digestive tract has a much more difficult time recognizing and absorbing non-heme iron compared to the heme iron found in animal tissues like red meat.
It's harder to digest.
It has notoriously low bioavailability. You could diligently eat those iron-rich squares of chocolate and realistically only absorb a tiny fraction of a milligram into your systemic circulation.
But there is a nutritional biohack to solve this, and it is beautifully, elegantly simple. You don't have to just accept that low absorption rate. You can mathematically multiply how much iron your body absorbs by pairing the chocolate with the right biological wingman, vitamin C.
It's a fantastic synergy.
If you consume that dark chocolate alongside a robust source of vitamin C, like eating a few slices of a fresh orange, a handful of strawberries, or even just drinking a glass of water with a heavy squeeze of fresh lemon juice, the chemistry in your stomach actively changes.
Walk us through the chemistry.
The ascorbic acid physically binds to the non-heme iron in your digestive tract. It actually alters the chemical valence state of the iron, converting it into a form that the intestinal walls can easily recognize and absorb. By introducing vitamin C, you are exponentially increasing the absorption rate. You are physically unlocking the iron that is trapped inside the chocolate matrix.
It is a perfect, actionable demonstration of the food synergy we discussed at the very beginning of this deep dive with the ancient Maya and their spices.
It all comes full circle.
It does. And speaking of actionable advice, we need to address a very practical, real-world application for the listener who has been tracking with us this entire time. There is undoubtedly someone listening right now who is thinking, this science is undeniably amazing, the cardiovascular data, the brain volume, the gut microbiome. I want all of it. But I have tried 85% dark chocolate before, and I genuinely despise the bitter, astringent taste. It tastes like dry dirt to me.
I hear that all the time.
How does that person access these profound physiological benefits if their palate actively, violently rejects the medicine?
I have to speak directly to that listener right now because I've absolutely been in your shoes. The biggest mistake you can make is trying to jump straight from a lifetime of eating sweet commercial milk chocolate directly to an 85% or 90% dark chocolate bar.
It's too much of a shock.
It will completely shock your palate, your brain will reject the extreme lack of sugar, and you will hate the experience. You have to actively build a tolerance and systematically train your taste buds, much in the exact same way you would if you were learning to drink black, unsweetened coffee or a very dry, tannic red wine.
So what's the protocol?
I always give people a specific roadmap for this. Do not start at 85%. Start at a 40% or 50% dark milk chocolate. Stay at that level for a few weeks until your brain registers that level of sweetness as completely normal. Then graduate to a 70% bar. Let your palate slowly adapt to the reduction in sugar and the sudden introduction of those astringent tannins and polyphenols.
It takes time to downregulate the sugar receptors.
Exactly. Over the course of a few months, as you break your neurological reliance on hyper-sweetened foods, you can comfortably work your way up to an 85% or even a 90% bar. And here is the real magic of that process. As your sugar addiction breaks, the bitterness naturally fades into the background. You will actually start to taste the incredibly complex, fruity, floral, and earthy notes of the raw cacao that the sugar was previously masking.
That is a highly practical, psychologically sustainable approach to implementing a long-term dietary change. And as the listener makes that gradual journey up the percentage ladder, There is one final, absolute, non-negotiable rule they must follow when they're inspecting the ingredient label on the back of the bar.
The ultimate red flag.
Regardless of whether it is a 50% bar or 90% bar, they must verify that there are absolutely no hydrogenated fats or partially hydrogenated oils listed in the ingredients.
Why do companies even use those?
Manufacturers, particularly of cheaper or highly processed chocolates, sometimes utilize these industrially altered oils to manipulate the texture, artificially raise the melting point, or drastically extend the shelf life of the product. Hydrogenated fats are trans fats. They are arguably one of the most highly inflammatory, biologically damaging substances you can possibly ingest.
They wreck the cardiovascular system.
They actively and aggressively damage the endothelial lining of the blood vessels. Consuming a chocolate bar that contains trans fats would not just negate the cardiovascular and nitric oxide boosting benefits we have meticulously outlined today, it would actively induce the exact vascular damage you were trying to prevent.
It is an absolute, unequivocal deal breaker. If you turn the bar over and see the words hydrogenated or partially hydrogenated anywhere in the ingredient list, you put the bar immediately back on the shelf. No exceptions.
Agreed.
All right. We have covered a massive amount of incredibly dense structural biology today. Let's pull all of these complex threads together into a unified summary. What exactly have we discovered about this specific food?
We've covered a lot of ground.
We've learned that clean, high-percentage, undutched dark chocolate is not merely a confectionery treat. It is a potent, dual-action vascular dilator that lowers blood pressure by boosting nitric oxide and inhibiting ACE enzymes, actively protecting the architecture of your heart. It is a highly targeted 16S sequenced microbiome fertilizer that can actively alter your subjective mood and reduce negative effect by selectively feeding Blautia opium in your gut.
It rewires the brain, too.
It is a neuroplastic brain volume builder that reduces systemic fatigue and structurally enhances your gray matter density through angiogenesis. And despite everything we intuitively believe about chocolate, it is a mathematically proven diabetes defender, provided you stick strictly to the high-percentage cacao and ruthlessly avoid the metabolic traps of milk and refined sugar.
The overarching, unifying takeaway from all of this data is that scientific knowledge is only truly valuable when it is deeply understood and practically applied to your daily life. We are living in an era of unprecedented, often overwhelming information overload. But taking 3 seconds to physically turn a chocolate bar over in the grocery aisle, checking the specific cocoa percentage, scanning the ingredients for hydrogenated oils, understanding the consequences of Dutch processing, and verifying third-party heavy metal testing online, that small, deliberate, everyday act of critical thinking pays massive, compounding physiological dividends over the entire course of your life.
It literally changes your entire biological trajectory. And as we wrap up this deep dive today, I want to leave you, the listener, with one final lingering thought to mull over on your own time. We have just spent the last hour meticulously validating the ancient Mayan reverence for cacao using incredibly modern cutting-edge tools, things like fecal 16S RNA sequencing and complex spline regression models. We essentially used the absolute pinnacle of 21st century science to prove that their indigenous food of the gods physically restructures our gut microbiomes and our brain's gray matter today.
It's poetic, really.
So it begs a much larger question. What else were they right about? What other ancient indigenous culinary traditions, regional herbal preparations, or specific spice pairings are we currently dismissing as mere cultural folklore or primitive cooking, just waiting for a modern multi-million-dollar clinical trial to finally prove that they are, in fact, the ultimate epigenetic biohacks? Keep exploring, keep questioning the world around you, check your labels, and we will see you on the next deep dive.